Myself, Dr. Sushma Jain, Associate Professor Chemistry, Government Dungar College, Bikaner. Today, I shall discuss about disconnection approach. In this topic, I shall discuss about the Robinson annulation. It is a cyclization reaction of products of Michael reaction. This Robinson annulation is the extension of Michael reaction and important way to make a six-membered ring. This is the example in which we carried out the disconnection of the molecule. After disconnection of this molecule, we get 1,5-dicarbonyl compound here, and on disconnection at this position of this compound, this disconnection is called 1,5-dico because the 2 carbonyl group is present at 1,5 position and the disconnection is carried out between C3-C4 carbon atom. So 1,5-dico disconnection is carried out, and after disconnection we get 2 synthetic equivalent, third and fourth. For the synthesis of this target molecule, first these two compounds, third and fourth, are the starting material. In this reaction, when we carried out the synthesis of the target molecule, the second compound convert into the compound first. In this process, the addition reaction and the cyclization reaction is carried out spontaneously. So the conversion of the compound second to compound first, when we carried out the synthesis of our target molecule, the reaction is called Robinson annulation, or in other words Robinson annulation. So with the help of Robinson annulation, we convert the open chain compound into the cyclic structure compound, ring structure compound. Here I listed the synthesis of a target molecule. These are the two starting material obtained by the disconnection of this compound first, which is the target molecule. Now the example of another example for the disconnection approach. This is the target molecule. On disconnection at this position, we get this type of the open chain compound. Here the one ring is opened here and one is exist as it is. So this here the ring is open and we get the 1,5-dicarbonyl compound here, 1, 2, 3, 4 and 5, the carbon atom and the carbonyl group present at position 1 and position 5. So when we carried out the disconnection of this compound, we carried out the disconnection between C3 and C4, and we write here 1,5-dico. So after disconnection, we get 2 synthetic equivalent. These are the synthetic equivalent which obtained after the disconnection of compound this. So by starting these two synthetic equivalent, we easily get our target molecule. Now the synthesis of our target molecule. Here the reaction of this compound with the second molecule of the synthetic equivalent in presence of KOH, we get this intermediate molecule, and the reaction of this intermediate molecule with hydrogenated pyrrole in presence of acid in benzene, we get target molecule. The Robinson annulation reaction is very useful in the steroid chemistry because in this by this reaction we can easily convert the one cyclic compound into the another cyclic compound, and we can easily synthesize the cyclic ring cyclic compound during the synthesis process of the steroid. Now the another example of the Robinson annulation is that here it is the uh, ketone, acetone, this is acetone, and this is the alpha beta unsaturated carbonyl compound. When the reaction of this ketone with base, the proton removal is takes place from here, so this carbon becomes negatively charged, and this acetone converted to this type of the anion CH3COCH2 minus. And in the second molecule here, this is the alpha beta unsaturated carbonyl compound. The pi bond electron is displaced to this oxygen atom, so this carbon becomes positively charged and the oxygen becomes negatively charged. At the same time, the pi bond electron of this carbon and this carbon shifted to here, so one double bond is formed between this positively charged carbon atom and this negatively charged carbon atom. So this double bond is shifted between this carbon and this carbon atom, and it is uh, demonstrated by here. This is the double bond, and this carbon becomes positively charged due to the displacement of the pi electron to this carbon atom. So this positively charged carbon of this molecule and the negatively charged carbon of this molecule form a covalent bond here. So this bond is prepared by the reaction of this negative ion and this molecule, and after reaction we get this molecule. Now the due to resonance, the electron delocalization is takes place here. The two electrons from oxygen atom displace between this carbon and oxygen and form a covalent bond. So this type of the double bond is formed here, and the electrons from the pi bond displaced to here, and this carbon become negatively charged, and when we react with the water molecule, the proton abstraction is carried out by this carbon atom, so negatively charged carbon atom becomes neutral. So we get finally this type of the compound. It is 1 2 3 4 5 1 5 dicarbonyl compound. Now when this 1,5 dicarbonyl compound react with base, the base removed a proton from this compound, and here, and water is liberated here, so here CH2 is remaining here. This CH2 is illustrated by CH2 minus. CH2 is minus is formed here, and when the delocalization of electrons, or we can say the displacement of the pi electron from carbon to oxygen atom, this oxygen atom becomes negatively charged and this carbon become positively charged. So this carbon positively charged carbon and this negatively charged carbon atom react with each other and form a covalent bond. So we get this type of the ring structure from this open chain structure. The reaction of this ring structure with water molecule, the hydrogen is abstracted by this O minus, and we get another molecule of this type OH. O minus is converted into the OH. Here the electron displacement is takes place from more electronegative atom oxygen. So this carbon becomes positively charged and this oxygen becomes negatively charged. At the same time, in the presence of base, the hydrogen as a proton is removed from the molecule. So this carbon becomes negatively charged and this is positively charged, form a covalent bond. So this covalent bond is appear in this molecule here. This covalent bond is prepared by the removal of the hydrogen as a proton from here, and here the positive charge is created by the displacement of the pi electron towards the oxygen atom. So here C and C form a covalent bond, C plus here and here C plus and here C minus, form a covalent bond. This is appeared by this covalent bond. So the next molecule of this type is formed here, and the in the presence of base the proton removal takes place, so the water molecule is liberated here. In the next step, the due to resonance, the electron displaced between this oxygen and this carbon atom, so this double bond O is formed, and the pi bond electron is displaced towards this carbon atom, and this carbon atom becomes negatively charged. At the same time, the OH is removed as OH minus. So this OH minus, in the presence of proton, this OH minus is removed as a water molecule, and the proton which is present in the ring here, which react with OH, so water molecule is removed, and this carbon becomes positively charged. Here this carbon become negatively charged, so here double bond is created between these two carbon atoms. So this the created new double bond is between these two carbon atom, and in this way we can easily prepare the alpha beta unsaturated ketones. By the Robinson annulation, the ring cyclization reaction is takes place, the ring formation is takes place here. The another example for the cyclization is that we take this type of the compound, this is the cyclohexanone, and in the presence of base, the base removed hydrogen as a proton form here, and this carbon becomes negatively charged. At the same time, the bonding electrons displaced towards the oxygen atom, so this oxygen becomes negatively charged and this carbon becomes positively charged. Here this positively charged carbon and this negatively charged carbon form a covalent bond which is appeared in the second molecule. Here this covalent bond is prepared and O becomes negatively charged. This compound react with the another molecule here. This is the alpha beta unsaturated carbonyl compound. Here the electron displacement it takes place, the carbon to oxygen atom, so oxygen becomes negatively charged and this carbon becomes positively charged. At the same time, here the pi bond electron is displaced towards this C2 carbon atom, so C1 carbon atom becomes positively charged and this is negatively charged. Here negative and here positive form a covalent bond, so this here a bond is created here, and this becomes the, because of the, this is the positively charged and this becomes the negatively charged, because the electrons due to resonance, the electrons of oxygen atom displaced between this oxygen and this carbon atom, so double bond O is prepared here, and the double bonded pi electron is shifted to here, so this carbon is negatively charged. This negatively charged carbon atom and this positively charged carbon atom form a covalent bond here, which is appeared by this covalent bond, and here the double bond is created between C2 carbon and C3 carbon atom. So we get the another structure of this type. Here the further due to resonance, the electrons of oxygen atom delocalized and displaced between the oxygen and carbon form a covalent bond here. This double bond pi electron also displaced to this carbon atom, so this carbon atom becomes negatively charged. This negatively charged carbon atom abstract the proton from the water and it becomes neutral, so here this carbon atom is neutral and single bonded single bond here, and this oxygen atom form a covalent bond, oxygen bond electron form a covalent bond between this oxygen and this carbon atom, which is appeared here, the double bond C double bond O. So we get the 1,5 dicarbonyl compound. From this 1,5 dicarbonyl compound, the reaction of base with this compound, the base abstract a proton from this compound from here, and water molecule is liberated. So this carbon becomes negatively charged. Here this carbon has a CH3 and we get CH2 minus after the reaction. CH2 minus, C double bond O, CH2, CH2, then here CH2, 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 C double bond O. This is the intermediate molecule, and the carbon atom here has contain oxygen atom with double bond, C double bond O. We can say carbonyl group, C double bond O. The electron of CO group is displaced toward oxygen atom. So oxygen becomes negatively charged and this carbon becomes positively charged. Here CH2 minus form a covalent bond with here C plus. So a new bond, covalent bond is formed here, and the ring is cyclized here, and this cyclization is called Robinson annulation, and here we get this type of the product in which the oxygen has the negative charge and the open chain here is converted into the closed structure, closed chain cyclic structure, and we get the this type of the molecule. The reaction of this type of the molecule with water molecule, the O minus abstract proton from the water and converted into the OH. This compound after converting into OH, we can return into this type by inverting this compound. We get this compound. So the O minus is converted here into the OH. Now in this structure, the electron delocalization towards the oxygen atom, electron displaced here due to resonance, and O becomes negatively charged, and here this carbon becomes positively charged. At the same time, here the hydrogen is removed from this carbon atom as a proton, so this carbon becomes negative charge and this is positively charged carbon form a covalent bond. So here this covalent bond is appear in the structure, and this is the OH. Now in the next step, the OH is removed, and due to resonance the electrons of oxygen atom form a pi bond between carbon and oxygen atom, and this pi bond electron is displaced to here. So this carbon becomes negatively charged, and in the presence of H plus ion the OH is removed, and OH is removed as a water molecule H2O. So this carbon becomes positively charged. This carbon and this negatively charged carbon form a covalent bond. So this covalent bond is appeared here. This is the new forming covalent bond, and we get the alpha beta unsaturated compound, cyclic compound, and this compound is very useful in the steroid chemistry for the preparation of the a lot of steroids. So with the help of Robinson cyclization reaction, we get cyclized the open chain compound into the cyclic compound, and we can say this is the extension of the Mannich reaction, in which the Mannich reaction product is not cyclized. The cyclization takes place by the Robinson annulation. So Robinson annulation reaction has very importance in the steroid chemistry for the preparation of a lot of steroids. Thank you.